computer.
When I had the computer, yeah. My desktop.
Why did you
Maybe
get
we shouldn't have gone back.
Okay.
To go back, we never go back.
You said 25 on which side, Dee?
12.
12.
PC Master Race. That's okay.
Alright, so for number 12, or 25 on page 12, it says z to the 6th minus 1. And D is asking, how do you know how to break that value down? So our goal is to figure out what the A and the B values are. And A would be the cube root of whatever number is here or variable. B is the cube root of the number or variable that you're given. A cube root means you have 3 values that are being multiplied together. So if you think that I've got 3 z's that are being multiplied together, they have to have the exact same power for it to be a perfect cube. So if I have z to the 6th, z squared multiplied 3 times is how I would make z to the 6th. Because if you add the exponents, 2 plus 2 plus 2 makes 6. So that means the cube root of z to the 6th is z squared. So when you're looking at powers, you kind of have to ask yourself, if I have that variable, what power would be repeated 3 times, because that's the cube root of the power. And then in this case, b is just 1. So if we were using the pattern, this is a minus here, so I have z squared minus 1, the same sign. And then my next one is taking the a and squaring it. So if I square z squared, I get z to the 4th. And then the same sign times ab here, so z squared, and then always addition, and then b squared. So there was a problem right before this, number 13. So if you look at number 13, there's an x to the 9th. So what would the cube root of x to the 9th be? X to the 3rd. But then there's a y to the 5th. And y to the 5th is y squared, and then just a 1. So that does not have a perfect cube because there are not 3 variables with the same exponent that would combine together to give us y to the 5th. So 13 is not factorable. If this was y to the 6th, then it would work. If it's y to the 9th, it would work. If it's y to the 12th, it would work. Essentially, it needs to be divisible by 3 for it to work. D.
And then for number 7, with the 4a.
So number 7, what would you factor out?
Oh, 4.
So we could factor out a 4a,
Okay.
and then you would have 16a squared minus 1. It's not a difference of 2 cubes, but it is now a difference of 2 squares. So it's still factorable, just not using the cube pattern. Are there other questions either on page 11 or page 12, either side of that worksheet? So I have a factoring problem that I just wanted to go over with you. The following worksheet in your packet on page 13 is just a mix of any type of factoring problem that you could possibly see. That quiz is on Monday, so it's not just specifically going to be grouping or the sum and difference of cubes. You could have the sum and difference of squares, you could just have a GCF, you could have AC grouping, so it can be any kind of factoring that you would have done this year or last year, but any factoring you did last year, we've already talked about again this year. So I have this problem. If you could just like squeeze it somewhere on the side of one of those pages, see if you can get it to fit in. Or like I think the back page of the notes page was blank, so if you can find a back page that's blank. This is a common problem that students don't like because having the multiple variables in the problem seems to be the ones that people get tricked up on. So I thought we would just go over this as a little refresher that if you have 2 variables and it looks like it's in that trinomial form, just to remind you how to factor it. So we have 2x cubed y minus x squared y squared, and then minus 3xy cubed. So there are definitely cube terms in here, but it's not a difference of 2 cubes. So we can't use the sum or difference formula for cubes because you only are allowed to have a first term cubed and a last term cubed to use that formula. So when you have a trinomial, you're going to think of what can I take out, and then could it apply to the AC grouping? That's generally trinomial format, those 2 questions you would want to ask yourself. So Joe Andrews, is there something we can take out? Is there a GCF?
We could take out an x and a y.
Yeah, you could take out an x and a y, so that would be a GCF that we could pull out. And when you do that, what do you have left?
2x squared minus xy minus 3y squared.
Bless you. So that would be the first thing. Pull out whatever they have in common. And then a perfect square trinomial, not really working because these aren't perfect squares, but it would just be like that AC grouping trinomial because we have an ax squared, a bx term, and then a c term. So it's in that pattern. So if you think of AC grouping and the method that you would use to do AC grouping, you take the first term times the last term. Brad, what multiplies to be -6 but adds to be a -1? Right, -3 and 2. So AC grouping, take the first and last number, multiply them together. That makes a -6 in this case. We're trying to add to be the middle number, which is a -1. So when you use the AC grouping, you keep the first term. And then the middle term is now going to be the 2 factors. So it has an xy. My 2 factors need to have an xy. So he told me a -3, so that has an xy with it, and a +2. That also gets the xy. Because this middle term, we're just rewriting it by splitting it apart into those 2 numbers that it can add to become. And then -3y squared. Joe?
Wouldn't the -3xy be positive and the 2xy be negative?
If I have a -1 here, I need the bigger number to be negative. Because -3 plus 2 makes -1. So after you kind of split the center term apart into the separate factors, this is where the grouping part comes in. So again, when you're grouping, don't put parentheses around those. Try and get yourself out of that habit if you were shown that habit. Either draw a line down the middle, or just kind of underline the 2 that you're looking at. But try and get out of that habit of putting parentheses, grouping symbols, and creating a multiplication problem when it really isn't yet. So if I take the term out of the first 2, Kristen, what would they have in common? An x, and you're left with 2x minus 3y. And then the last 2 we would take out a y, right? And you're taking out a positive y. So make sure you have a plus sign there because it's still not entire multiplication until we finish the grouping step. So if we take out a positive y, we end up with a 2x minus a 3y. So just because there were 2 variables in the problem doesn't mean the AC grouping can't work. It's just that you're going to have both those variables in the front and the back of those parentheses. So we have an x plus a y, that's what we pulled out, so that gets plugged in together. And then we have the 2x minus 3y. What else do we have in this answer? Joe?
The xy.
The xy. Yeah, that we pulled out initially. Most common mistake is for people to forget the GCF that you initially pulled out. Because you don't want to really kind of think about it when you're writing all this here. But don't forget to put it in the answer. So you pulled it out. We did the AC grouping, but it has to go in the answer. The answer should FOIL to go back to the original problem. Any questions with that? So when you see 2 variables, it doesn't just mean that you pull out a GCF and you're done with it. It could still apply to AC grouping if it's in that format of the ax squared plus bx plus c. Any questions with factoring? So homework is in your packet. It's just the next page, and it's, as I said, a mix of all the factoring problems that you could possibly see. The other homework is a finding errors worksheet, and that's due on Monday. I'm going to collect that from you. So essentially, there are problems here that somebody already solved, so they are solved for you. Your goal is to find the error in that mistake that the student made and correct it. So you're going to locate the error, whatever they did wrong, and there are mistakes in all of them, and then you're going to make the correction. So underneath the problem, I have what is the student error, and then right next to it, to redo the problem correctly. Next week, we will be working with rational equations, rational expressions. So getting to solidify the fact that no, a denominator can't be separated. You can't do any legal canceling or illegal canceling just by canceling one term. Remember, they're quantities grouped together. So that would be the goal here of trying to look at the worksheet. The last couple problems are power problems, just like we did on that algebraic atrocities worksheet as well. So this is due on Monday. It's not due tomorrow. Joe,
What is the page number for the review handout?
it's page 13.
13.
You have an answer sheet or like denominator, not factor.
Oh, the answer sheet is on the back of, yes. So your answer sheet to tonight's homework is on the back of the answer sheet from last night's homework, so I copied them front back, hopes to save the paper. Other questions? Any questions for your quiz today?
Okay, sorry. I never did this test in this class.
Brad, did you know there was a quiz? Oh. I think before you left yesterday, I reminded you.
Yes. I
He didn't
knew
know
it.
who heard it.
Hey, I'm on top of the ball today.
Because I told Gio earlier, I was like, what's the quiz? And he's
Yeah,
like,
you
what?
told me in homeroom and I was like, oh.
If you would pass your folders forward, I'll get them off your desk. Thank you. Don't mind just putting
That's
this
so big, like, I really need to.
Did you just say I?
Joe had my folder.
Oh yeah. I have my own folder too. Here. I thought.
So if you look at the first problem, you're asked to use substitution for the first problem. Your answers should be exact, don't round. Make sure it's an exact answer. The second one wants you to use elimination, and then after you use elimination, you're asked to describe the graph and then state what the solution means. That's a two-part question. So describe the graph, state what the solution means, and then part C is it inconsistent or consistent? For the other question, it's a word problem. Make sure you're writing a system, which is two or more equations that pertain to the word problem that you're given. Label your variables as well as writing the system of equations. I feel like I said those same words first period, but maybe they forgot once they got to that question. Sorry, I know, it's harsh.